In this practice video, we're going to look at the four common types of exam questions about the structure of the atom. We'll look at how to approach them, what examiners are looking for, and some of the common mistakes students make. Question type 1 is all about the properties of subatomic particles. Okay, so here we have a typical exam question on the properties of subatomic particles. In this case, we're being asked about the relative charge and relative mass of a proton and a neutron. All we need to do is fill in the correct details in the correct column. Protons have a relative charge of +1 and a relative mass of 1. Neutrons have a relative charge of 0 because neutrons are neutral, and they have a relative mass of 1. In terms of marks, it's 1 mark for each correct row, so you need to know both the relative mass and charge of each subatomic particle. So where do students go wrong? Well, the first common mistake is not including the magnitude of the charge, so just putting a plus sign for the proton. Yes, protons are positively charged, but we also need to include the relative size as well as the sign. The second common mistake comes from rote learning the orders of these numbers from a table. Most textbooks, revision guides, and indeed my own resources usually give the relative mass first and then the relative charge. Notice how this question doesn't. Unfortunately, this does catch students out, and although they write the correct values, they put them in the wrong columns. Knowing this, examiners like to vary the order of the columns in the table. Here's another example. It's still the same basic question, recalling properties of subatomic particles, but this time they're asking for the relative mass first and then the relative charge. They're also asking about different subatomic particles, a neutron and an electron in this case. So the relative mass of a neutron is 1, and its relative charge is 0. For the electron, I'm putting the relative mass as Na. This is because I know mark schemes will always accept that. Some mark schemes will accept 1 over 2000, others want you to say 1 over 1800, which is a little bit more accurate. But they all accept negligible or Na, so I would recommend going with that one to be on the safe side. The relative charge of an electron is -1. Again, it's 1 mark for each correct row. As for the common mistakes, well, it's the same as before, not including the magnitude or size of the relative charge on the electron, or putting values in the wrong columns. So make sure you're reading the question carefully and paying attention to what value goes where. Our next type of question is all about definitions. Now, there's only 2 key definitions we've covered in this topic, and they both come up as part of larger exam questions. Firstly, we're being asked to define the term atomic number. Assuming you've learnt your definitions, this is nice and easy. The number of protons in the nucleus. 1 mark that's generally well answered by students. Secondly, state the meaning of the term mass number. Well, we know that the mass number is the number of protons and neutrons in the nucleus, and again, it's 1 mark. Now, this is a question that students do make mistakes on, and that is because they confuse mass number with the relative atomic mass and give the definition for that. You just need to make sure you learn your definitions thoroughly with frequent revision. But also read questions carefully. There's a reason I use a highlighter when looking at exam questions. I'd suggest you do this too. It just helps focus your mind on the key parts of the question. So our third type of question is all about interpreting nuclear symbols. And there's a couple of ways examiners do this. Let's take a look. So here we have atoms of tungsten, tungsten 182 and tungsten 186. Firstly, notice how they haven't given us the atomic number with these nuclear symbols. This is very common in exam questions, and it just means that you need to look them up on the periodic table. Part 1 asks us to deduce the number of protons in tungsten 182. Well, we know the number of protons is always equal to the atomic number. So if we find tungsten on the periodic table, we can see that the atomic number is 74, and so we must have 74 protons. Nice, easy, 1 mark. Part 2 asks us to then deduce the number of neutrons in tungsten 186. We know that the number of neutrons is always equal to the mass number minus the atomic number. We've just looked up the atomic number for tungsten, so 186 minus 74 leaves us with 112. 1 mark. Now, weirdly, this is something students frequently get wrong, and examiner reports identify that a number of students don't know how to calculate the number of neutrons. I guess it shows the importance of mastering the basics and not overlooking content because it seems simple. Now, for our next question, we're still looking at interpreting nuclear symbols, but we then have some application to do afterwards. We're told that Table 1 shows some information about fundamental particles in an atom. And if we look at the table, which, by the way, you absolutely should. In fact, any time you're given a table, a graph, a method, a diagram, or any piece of information in an exam, look at it, read it, take the time to process what it's telling you. It's there for a reason, so make sure you actually read it and think about what it's telling you. Well, this table is telling us the actual mass of each individual subatomic particle, including the electron. Now, this is a bit of a hint. It's telling us not to ignore the mass of any electrons like we typically do when we're dealing with relative masses. We're then given the nuclear symbol for a hydrogen atom and asked to calculate the mass of the hydrogen atom. So firstly, we need to know the numbers of each subatomic particle. Hydrogen has an atomic number of 1, so 1 proton. The mass number here from our nuclear symbol is 1, so 1 minus 1 leaves me with 0 neutrons. And then finally, as it's an atom, it's going to have the same number of electrons as protons, so 1. So now we just need to add together the masses for 1 proton and 1 electron, which gives us a total of 1.6734 times 10 to the minus 24. 1 mark. Where students go wrong with this is by getting the wrong number of subatomic particles, and there's 2 probable reasons for this. Firstly, probably a consequence of how we actually teach atoms. We always say that atoms are made up of 3 subatomic particles: protons, neutrons, and electrons. Now, for most atoms, that is absolutely true, but for some atoms of hydrogen, it isn't. Most hydrogen atoms are actually only made up from 1 proton and 1 electron. But because we learn that atoms are made up of protons, neutrons, and electrons, students want to say that there must be a neutron. So to combat this, stick to the process. We know that the number of neutrons is always equal to the mass number minus the atomic number. Stick with that, and you can't go wrong. Secondly, is forgetting to include the mass of the electron. We're so used to ignoring the mass of electrons because they are so small that questions like this just catch people out. It's a sneaky one from the examiners, but one worth looking out for. Now, there are other variations of these types of exam questions. Multiple choice questions where you're asked which atom has the most or least neutrons, or multiple choice questions asking you which row has the correct number of protons, neutrons, and electrons for an atom or ion given the nuclear symbol. And you can see examples of these by accessing the structure of the atom exam questions on my website. There's a link below. Now for the final type of question, drawing nuclear symbols. For this question, we're told that an atom has 2 more protons and 3 more neutrons than an atom of chromium-52. We're asked to deduce the symbol, including both the mass number and atomic number for the atom. So let's have a think about how our nuclear symbol would change. Our atomic number will increase by 2 as we're gaining 2 protons. The mass number will increase by 5, 2 from the protons and 3 from the neutrons. So if we grab our periodic table and find chromium with its atomic number of 24, we know that our atom will now have an atomic number of 26, and so it must be iron. This gives us 2 of the 3 components we need, our symbol, Fe, and our atomic number, 26. For the mass number, we just need to add 5 onto the mass number given in the original question. So 52 plus 5 becomes 57, and we add that onto our symbol in the correct place. It's 1 mark for all 3 parts being correct. Now that's quite a bit of work for 1 mark, but unfortunately that's sometimes the case. So where do students go wrong? Well, the most common mistake is giving the relative atomic mass from the periodic table rather than calculating the mass number. Students also sometimes only add 3 to the mass number for the additional neutrons, forgetting that protons also contribute to the mass, so watch out for that. Lastly, a very similar question, but this time in multiple choice format. We're asked which atom has 1 more proton and 2 more neutrons than phosphorus-31. And this time, they've kindly given us the atomic number for phosphorus, which is 15. So same as before, our atomic number will increase by 1 due to the extra proton, and then our mass number will increase by 3 because of the 2 extra neutrons and the 1 extra proton. This immediately rules out 2 of our possible answers, as we know our mass number will become 34. So both options with a mass number of 33 are incorrect. Those are there for the students who forget the extra proton also increases the mass number as well as the atomic number. So we're now left with two options, but the correct answer must be D, as we cannot still have an atom of phosphorus. Remember that the number of protons defines an element. As soon as you change the number of protons, you change the element itself. And this is the common mistake students also make. They get carried away having worked out the new atomic and mass numbers and tick the first box that matches those without thinking it through properly. And that's all of the typical exam questions you'll come across on the structure of the atom. You now know exactly how to approach them in the exam and the mistakes to avoid. But if you'd like more practice, don't forget to head over to my website where you can find additional exam questions for this topic. They're the perfect way to consolidate what you've just learnt. And if you're following along with the full series, you can watch the next Learn video by clicking on the screen now. Don't forget to hit the like and subscribe button if you found this useful. It really helps the channel, but also ensures that you don't miss out on future content. Thanks for watching, and I'll see you in the next one.